Area approximation is our topic today, and under this area approximation, I want us to use the method of trapezoidal rule, specifically on the derivation part. I want us to know how to approximate an area of a given irregular object using trapezoidal rule. Of course, we understand very well that area of irregular shape is mostly estimated. That's what we know. And there are quite a number of methods that we can actually use to estimate this area. One of them being trapezoidal rule. And that trapezoidal rule is what we want to look at into this lesson. A trapezoidal approach is a method of approximation. And this method mostly involves a division of a given irregular shape into trapezia, then finding the area of each of those trapezia, then summing up and getting the total area of that given irregular object. Now, I want us to consider a general figure 1. The ordinates of the trapezia are actually given as y0, y1, y2, and y3 in that order. Now, to get the height, which is uniform across each trapezium, we'll actually apply the following formula or the following relationship, where we'll take the difference between B and A, and then we divide by the number of strips or the number of trapezium. Remember, for this case, strips are the number of trapeziums, while ordinates are the parallel heights of the trapezium, because we know the perpendicular height of each trapezia is uniform, which is actually given by h equals to b minus a divided by the number of strips or trapezium. So in the figure that is appearing alongside, you can see that the parallel heights are labeled as y0, y1, y2, and y3. There are 4 ordinates, but there are 3 strips. So you can imagine that the number of strips are less by 1 if you are to compare with the ordinates. Now, from this figure 1, we can actually now try to find the area of each trapezium, because there are 3 trapezium, and we know that the area of a trapezium majorly is the sum of the parallel heights multiplied by the perpendicular height divided by 2. So we'll apply that formula across the 3 strips and then sum the total area to get the total area for that case. And by so doing that one, you realize that a half h is appearing on both cases, and therefore what we can do for this case, we can actually simplify the above equations by factoring out a half h and then remaining with y0 plus y3 into bracket plus 2 into bracket y1 plus y2, and so on like that one. So realize that apart from the first height and the last height, the other heights are appearing twice, and therefore in a general case for this, we can now sum up. If we assume now we have n strips, then that formula can be generalized into the appearing formula there, where we say the first height plus the last height twice the intermediate sum to get the total area of that particular irregular figure that is given. Follow me on the subsequent video to understand more and get more examples under this trapezoidal rule. Thank you, and God bless you.